1/2 e to the 2 theta sine of 3 theta minus what? 3/4 e to the 2 theta cosine 3 theta minus what? 9/4 antiderivative of e to the 2 theta sine of 3 theta d theta. And this is 4/4 over here, right? Bring over the 9/4 right? So that's going to be what? 13/4 antiderivative of e to the 2 theta sine of 3 theta d theta is equal to 1/2 e to the 2 theta sine of 3 theta minus 3/4 e to the 2 theta cosine of 3 theta and now divide by 13/4, which you divide by 13/4 on both sides, you multiply by what? 4/3. So that's going to multiply this by 4/3. I'm at 13ths. Sorry. I just changed the problem. So let's do this.
Ask before you do it.
Yes.
Say you did all that down to where you have, like where you drop down the picture, and you have problem 17 equals 1/2 2 theta 3 theta minus 3/4 and then minus the 9/4. What if somehow the way the function was worded turned out to be a plus 9/4?
This.
Yeah. Would you subtract it to the other side and set everything equal to 0?
You take it over to the other side and it become
Well, I mean,
negative.
if it wasn't 4/4 and 9/4, like if they were the same function exactly, just different signs.
Yeah.
Just different signs.
Yeah, you set it equal to 0, but you wouldn't get. The whole point of this problem is that this is going to be the same as this, so it's always going to come out like that.
So it doesn't matter whether it be negative on this side or not. Is it?
No, because if it was negative on this side, this would make this positive, and you'd come out with this. You're going to come out with this at the end of the problem, no matter what, because that's the way the problem is configured. This manipulation is all it is.
I just didn't know if the sign made any difference when removing it.
No, it's not going to come out and you're going to get. It's not going to come out where you're going to get something crazy. It's going to come out to where you're going to get this guy right here by itself most of the time, or you're going to multiply through by this, which I think that's where I was, right? So the antiderivative of e to the 2 theta sine of 3 theta d theta is equal to, I have no idea, 2/13. Help me out. Is it 2/13? E to the 2 theta sine of 3 theta.
No, it should be.
No. 2/13, and then I'm going to distribute it there also. So that would be 3/13, right? Minus 3/13 e to the 2 theta cosine of 3 theta plus c. And let me look at it one more time and see if there's anything you could factor out. You could factor out 2/13 e to the 2 theta if you wanted to. Let's see if they did it. Let me see what they got. What number was this?
17.
They got 113. They factored out 113 e to the 2 theta. I don't know why they factored out 113. Oh, to get 2 and 3. That's all. We got the right answer. It says 113 e to the 2 theta times 2 sine 3 theta minus 3 cosine 3 theta. Is that what? Yeah. So they just wanted a 2 and they wanted a 2 here and a 3 here, so they just factored out 113. Alright, next section y'all have in this section, I think is just, hold on, trigonometric, yeah, that's what I thought it was. These are not that difficult. 7.2, trig integrals. And we'll start with something simple. Antiderivative sine 5th power of x cosine dx. Now what do you notice about this? If I set u equal to the sine of x, what's du? Huh? Du is equal to cosine dx, right? Cosine of x dx. So technically I have what? U to the 5th du, right? So antiderivative of u to the 5th du is what? U to the what? U to the 6th over 6 plus c. And what is u? U is the sine. So sine 6x over 6 plus c, or 1/6 sine 6x plus c. Now that's the simple one. The scale from 1 to 10, that's about a 1. Try another one. Now this one you're going to kind of cringe on. Pull up the old trig identities. Not the Pythagorean, because that would just cause a mess. Dang old double angle, dang old half angle. Alright, we'll pull them up on the screen. Because y'all done forgot them, right?
Mm-hmm. For sure.
Dang old trig identities. Just remember sine squared, take the square root of both sides. That'd just be 1 plus, yeah. That would work. 1 minus cosine theta over 2. 1 plus cosine theta over 2. That would work. So you're squaring both sides. So you gotta remember, if you're squaring both sides, the sine squared identity here. This is the sine of theta over 2. But we don't have theta over 2. What do we have? We have sine squared, right? So sine squared takes out the what? Takes out the radical, Hubert. So we got, for the sine squared of x, we have 1 minus cosine over 2. For cosine squared of theta, we have 1 plus cosine over 2. So those two are going to go in without the radical right here. So you've got the antiderivative of 1 minus cosine x over 2 times 1 plus cosine x over 2 dx. Now it's just a little bit of algebra.
Could you just leave the other one as cosine squared, or would you have to sum those up?
I'm sorry, what?
Could you just leave the cosine squared? Will you have to use the identity for it?
Well, you want to change it because now you can factor out a 1/4. And you factor out a 1/4, see what you get. It'll make it easier to work with. Then you have the shortcut. All the rest of it's out. Look here. Look, just watch this one step. You ready? And what do you got?
Sine.
Shortcut number 3. A plus b times a minus b. Which is a squared minus what? B squared. This is nothing but manipulation. Here's the problem on the assembly line. Here's the problem with the machine. Here's the problem with the take it apart. Put it back together. 1/4 antiderivative of 1 squared minus cosine squared x dx. And now what is this?
Sine.
Break these two up. 1 dx minus the antiderivative of cosine squared x dx. That's cosine 2x. So I messed up. This is 2x by the identity. Cosine 2x squared 2x. My bad. And that would be total squared. And I do have it squared right here. And then you can change that cosine squared 2x into identity again and break it up. Be 1 plus cosine 4x over 2. Using the same identity. this over to the next board. I hate when it does that. As soon as I do one thing, it flips that little button and I hit the wrong button. I don't know why it does that. As soon as I go to the next, well, it didn't do it that time. So that's going to be 1/4 times the antiderivative of 1 dx minus the antiderivative, and you can rewrite this as the cosine of 2x squared dx if you want to. Because the square here gets rid of your radical, so you can rewrite it according to that identity. So that would go away, and that's going to be 4 theta.
Where'd you get the cosine 2 theta?
Hmm?
Where do you see the cosine 2 theta?
Well, the way this works out, since this is cosine, hold on, let me get out of this. Back here, cosine squared and sine squared by the half angle, come out with 2 theta, 2x over 2 right here, 2x over 2.
That wasn't in your tree identity sheet.
It should be. Yeah, because of the divided by 2 right here. It would come out to be 2 theta. You're going to come out with 2 theta right here. And that would be 1/4. And we know that the antiderivative of dx is x minus, and that's going to give us 1 plus 4x, 1 plus cosine of 4x over 2. So that's going to be antiderivative of 1 plus cosine 4x over 2 dx. And now you're going to break that up because that 1/2 will come out. And then you'll be able to work with this. So that will be 1/4 antiderivative of or bracket x minus 1/2 antiderivative of 1 dx plus, well, no, not 1 dx, but 1 plus cosine of 4x dx. And now you can break this up and get that cosine of 4x, which would be the antiderivative. Take it to the next page. cosine of 4x. So you're going to need a 4dx. So you're going to have to multiply by 1/4, and then the antiderivative of cosine is what? Sine? Yes, no, maybe. See? Did it that time. It only does it one time. So, that'd be 1/4 x minus 1/2, and then I'm going to put brackets here, and the antiderivative of 1 dx plus the antiderivative of the cosine of 4x dx. That'd be 1/4 x minus 1/2 brackets. Antiderivative of that's going to be x plus, and then cosine of 4x dx, we need a 4 here and a 1/4 here. And the derivative of the the antiderivative of the cosine is the what? Be the sine, so that'd be 1/4 sine of 4x plus c. And then we can 1/4 here. Let's see, we've got to be careful here because we've got to distribute this. Let's see, this first. So that'd be 1/4 brackets x minus, that'd be 1/2 x plus 1/8 x, or 1/8 sine of 4x plus c, and then distribute the 1/4. That's going to be 1/4 x, 1/8 x, and 1/32 x, and that'll take care of the brackets. You can factor out if you want to, but that's what I got. The 1/8 x and the 1/4 x you can combine, and 1/32 sine of 4x, mine, I think I came out with, my final answer is 1/8 x. Would that be correct? What's 1/4? Change that to 2/8? Yeah. 1/8 x plus 1/32 sine of 4x plus c. Change that to 2/8. And that'll give you a 1/8 x. And that's the final answer. And of course, we'll go over more of these when y'all come back, if we don't have another obliteration day on Tuesday and Thursday. I'll make up some homework for these two sections, 7.1 and a little bit of 7.2. Is everybody here today? Except for Mr. Fowler. I think everybody's here today. Y'all go over here, I got you. Somebody turn off my button, please. And I will